Good evening, everyone.
Good evening, sir.
Okay. Last class we had discussed position of alphabets, position of a word in a dictionary made from only words built from that alphabet. Correct. Today we'll start. I'll give you a bonus question initially, and after that, uh, we will start with class questions that I'll be discussing. Okay, so this will be bonus question. Let n is equal to 3 to the power 31 times 2 to the power 19. Find the number of factors of n square that are less than n and do not divide n. Okay, this is a considerably tough question, but based on the contents of today's class, you might be able to solve it towards the end of this class. So I'll discuss it after 6 p.m. Okay, today I'll not be extending the class beyond 6, uh, 6:05 or 6:10. So get your doubts clarified as and when you have them. Okay, anyone has doubt in this question? What does it mean? There is a number n that is 3 to the power 31 times 2 to the power 19. You have to find the number of factors of n square, means this number squared, that are less than n and do not divide n. Okay, let's start with question number 21.
Excuse me, sir.
Yeah.
Sir, in the messages, your name is not coming. So, whom should be message? Transitions Lab Preparatory School host or Alan plus co-host?
You can message Alan plus
Okay,
co-host.
sir. Thank you, sir.
Yeah. Uh, where should I start with? Okay, question 21. How many four-digit numbers are?
Sir, is my answer for bonus question correct?
1 second. Sumit, 1 second. Sumit, correct. Sumit, you can keep working on that previous bonus question if you remember.
So, which bonus?
And then show that. Okay, this is question 21.
So, what's the previous one?
I'll bring it up. 1 second.
So, that 2 to the power 222 minus 6 like that. Oh, that was
1 second.
Sir, I just joined now only.
Okay. this was the previous bonus question which no one had got the answer to. Sumit, you can take screenshot of this. You can keep working on it. Rest of you can keep working on today's class's bonus question if you are done with question 21. Okay.
So just show that previous bonus.
Sanyu, not correct. Sanyu, the number should also be divisible by 4. 4-digit numbers using these digits that are divisible by 4.
Oh, so sorry. So I didn't read 4-digit. I read 5 digit.
No problem.
So now is it okay?
Yeah, Sanyu, correct. Pranshu, try again.
ब्रो माइक 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 ऊपर माइक चेंज करो ऊपर से.
Arnab, correct. Shubhangi, not correct. Yashraj, try again. Tuba, correct. I'll give 1 more minute to solve question 21. Those who are done with 21 can try the bonus. Keep trying the bonus.
Make sure it's clear.
Sir,
So shall I try the bonus question or this question?
Do 21 first. Do 21 first.
So should I try the bonus one or this question?
Do question 21 first, then go to the bonus.
sir, I just joined now only, so
What I've done is I've started with question 21. If you're done with question 21, this is a slightly harder question. Bonus question is a significantly harder question.
sir, this
Which
is
will
my first class.
no problem. You can keep working on question
Try
21.
the previous bonus questions first.
Snigdha, not correct. Okay. I'll start with question 21. How many 4-digit numbers are possible using only digits 1, 2, 3, 4, 5? If the question had ended over here and like divisible by 4 condition was not there. Okay. General 4-digit number without repetition. Then you have the option of 4 digits. Each of these digits have 5 choices each. And then you will say 5 to the power 4, which is 625. But you have a restriction that the number should be divisible by 4. Did everyone understand that 4-digit number, a general 4-digit number you want to make using 1, 2, 3, 4, and 5? Each of these digits has option of having 1, 2, 3, or 5. So 5 choices per digit. So since every digit has 5 choice, I'll multiply 5 4 times and I'll get 625. Anyone has a doubt here? No one? Okay. So then now we have the condition K, a number is divisible by 4 if last 2 digits. One second. Are divisible by 4. Okay. So what are the last 2 digit combinations possible? Since we are allowed 1, 2, 3, and 4, the smallest number that is possible is 12, then 24, then 32, then 44, then 52. These are the only 5 2-digit numbers that can be made out of these digits 1, 2, 3, 4, and 5 that are divisible by 4. Can everyone verify this? These are the only possibilities. There are no more possibilities.
Yes, sir.
Correct. So this means Number of choices for last 2 digits is 5. Okay, this is first, second, third, fourth, and fifth. So number of choices for last 2 digits is 5, and first 2 digits also have 5 choices each. So total will be 5 times 5 times 5, and this is for that last 2 digits. So answer will be 125. Okay. Now try question 22. That is, how many numbers from 1 to 567 are divisible by 3? First of all, there are many parts to this question. A part is divisible by 3. B part is divisible by 5. C part is divisible by 3 times 5. And D part is divisible by either 3 and slash or 5. Okay. E part is divisible only by 3 or only by 5. Okay. There are 5 parts to this question. Try to solve it. And once you get the answer, put A some answer, B some answer, C some answer, and so on. Am I audible to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
And if you have done such questions, then you are very much very proficient in these type of questions. You can go back to doing bonus, either the previous class bonus or this class's bonus question. How many numbers from 1 to 567 are divisible by 3? How many are divisible by 5? Sinha, not correct. Sorry, Shuvangi, not correct. Sanyu, correct. Ranshu, not correct. Try again. Shubhangi, not correct. First part is not okay. First part, so at least I'll try solving for everyone so that everyone get to know what exactly is supposed to be done. How many numbers from 1 to 567 are divisible by 3? So for that, you can notice that 3, 6, 9, dot, 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 all the way up to 567 itself. Okay, you can write both included. Okay. All the numbers 3, 6, 9, all the way up to 567. These are the numbers that are divisible by 3. Correct. So what would you do? You can get the answer easily by doing 567 upon
Is
3.
my answer for that question correct? So previous bonus question.
You use calculator for it?
What, sir?
You used a calculator for it, or?
No, sir.
You calculated it by hand.
Yes, sir.
I don't have the answer in its expanded form, but I can verify it later. I'll verify it later and let you.
Sir, it's just the square of a 4-digit number.
Then it might not be correct. Okay, for A part, I hope everyone understands that you can divide 567 by 3 and you'll get 189. And this will be the answer for A part. Similarly, you can find the answer for B part, 567 divided by 5. That will give you 113.4. But you don't care about this 4. You just want this integer part of your answer. So 113 will be the answer for part B. Try the rest of the questions.
Sir, I said that of a 4-digit number, but not actually 4. So 0 would be there at the last.
Okay, okay.
So
Yeah,
actually it's a 5-digit number. 0 is at its last, sir. So it's a 5-digit. Without 0, it's a 4-digit. With 0, it's 5-digit. The number has 1 0 at its end.
Sir, can you check my answer?
just a second. Okay, a lot of you are giving the answers. I'll go one by one and check and correct it. Okay, Sanyu C correct. Tuba not correct. I think you realized the mistake. Snigdha correct answer. Arnab not correct. Sanyu correct. Harsh Satvi correct. Arnab correct. Harsh
So is my answer
correct answer.
correct, sir?
1 second. I am not 100% sure.
Sir, is there any more bonus question?
No, not yet. Do one thing, Sumit, you try attempting that question once again.
So this one and
Yeah, one second.
sir, which question?
No, I am getting a different answer. So you, that ant one, you try it again. Shubhangi correct. Yashraj, third one is not correct. Try
Sir, is
again.
my answer close or very different?
Nigda correct. Pranmay not correct. It's close,
Sir,
but okay. Should I start solving the rest of the questions? I'll do that. Question number C. How many numbers are divisible by 3 times 5? To do that, it is simple. You just take 567 divided by 15. That is the same as doing 189 that you had received over here by division of 3. You can divide 189 by 5 and you will get 37.8. But 8 is not necessary. So 37 will be your last. I mean, it will be the answer. Number of numbers divisible by 50. The interesting questions are D and E. Numbers divisible by either 3 and or 5. Okay, the way to do this is, some of you can keep trying this question. Tuba correct answer. Pranmaya correct. Tuba E part is not correct. Try again. So based on these questions, you can try doing the D part.
Please show the bonus question answer.
So is the answer 9-digit number?
Nah, that's not correct.
So sorry, sir. So 9-digit is not correct.
It's not correct.
So 4-digit?
No.
So what the bonus one, sir? That and so for
What?
that
Yeah. That is what I'm talking about. I know. Yashraj, correct answer. Okay. Question D, I'll start solving. The way to do question D is actually using inclusion exclusion or using Venn diagrams. What is happening actually is that these are all the numbers from 1 to 567. Okay, this is you can consider as your universal set for this question. All the numbers that are in question are existing inside this big oval. In this left hand circle, I'll say that numbers divisible by 3 will be all placed inside here. And in the right circle, numbers divisible by 5 will be placed here. So what you want to actually calculate in D part is the net contents of both these circles, which means that the numbers that are divisible both by 3 and 5, they must be counted only once. You can't do 189 plus 113 and say that that is your answer, because that will give you how much? 302. 302 is not the correct answer. Why is it not the correct answer? Because what will happen? There is this region of overlap between divisible by 3 and divisible by 5. This is the region where you'll put numbers divisible by 50. So the way to actually find the entire contents of both of these regions combined is numbers or answer to D is divisible by 3 plus divisible by 5 minus divisible by 50, or the contents of this overlap region, you will remove them once. Is everyone clear with this? So what you get in the end over here is that 189 plus 113 minus 37. This gives you 265, and that will be your answer. If I do it a bit using coloring, you can see I can color this first circle once. This is like considering the contents of this first circle. When I color the second circle also, what happens is this middle region gets a darker shade because it's part of a overlapped region. Correct. Now I'll have to erase it out manually. So I can take an eraser and remove it once. Of course, here if I erase it, it goes away completely. But I hope everyone gets the idea that I need to remove all the numbers that are divisible by 15 from this number, and you'll get 265. Now, if the question says E, numbers divisible only by 3 and only by 5, divisible only by 3 or only by 5. To get to that answer, some of you who have not answered it can try and get the answer.
Sir, now correct for the bonus?
Yes, Sumit, correct. So you added up all the terms, or did you do some other trick?
Sir, I did not add anything.
You have any other way of representing your answer?
Sir, I used binomial theorem.
Then you did some addition only, na?
Yes,
Otherwise
sir.
you okay.
Yes, sir. Binomial addition. I did.
So the result for this will be that
Sir,
I
it can be
remove
done
the
by that method also.
Which method?
Sir, it can also be done by binomial, sir.
Sumit, I'll discuss bonus questions later. Right now, E part is that you remove 37 from 265. The entire contents of this region is also removed. So you are left with 228. And this will be the answer to this question. Now, everyone can try this question. Question 23. Find number of 4-digit numbers starting and slash or ending in 3. Okay, you want number of 4-digit numbers that either start or end and or end in 3. Here also try to make a Venn diagram of sorts. The procedure that I'm showing over here is called inclusion exclusion. Eva not correct. Snigdha not correct. Snigdha, you have found 3 times the correct answer, I think. No, you close to 3 times the correct answer, but not correct. Shubhangi not correct. Harsh not correct. Tuba correct.
Sir, is
Arnab
my
not correct. Harsh not correct. Acha, should I explain this question? Shubhangi, are you saying me asking me to explain this question? 23rd. So your number can be either of this form. You have 3x, or you have some numbers x, 3. Okay, this is what is required. Yashraj not correct. Purbayan not correct. Snigdha not correct.
Sir, is my answer correct?
Pranshu not correct. Sanyu, you have one more than the correct answer. I don't know how. Try again.
Yes, sir, I'll try.
Might be a typo. Snigdha correct. Okay, so when I say a 4-digit number, this is not a password. So 4-digit number cannot be starting with 0. Keep that in mind. Some of you have found almost correct answer, but have done a tiny mistake. 4-digit numbers cannot start in 0. Arnab not correct. Snigdha correct. I'll give 2 more minutes. After that, I'll discuss this question. Sumit.
Sir, in that set, sir, it can also be done by directly applying the combination formula and adding it.
Yeah, correct. Sumit, you specifically, if you want, I'll give you a tougher question. Everyone, I think you have written down question 23 in your notebook. So see, Sumit, in this question, you start at point A, and another ant starts at point A2. Okay. How many ways are there in which these two ants meet anywhere on the board? It's just that ant A1 can only move up and left, up and right. A2
And
can
right. And
and
A
A2
can
can
move.
move A2 can move down and left. A1 can move only left and right and up. Okay, they meet somewhere on the board. some random point. See, they can meet over here also, they can meet over here also, they can meet here also, anywhere on the board they meet. Okay. How many ways can this happen? Okay, try that. Rest of you keep working on question 23.
Sir, is it necessary to make any move?
No, they can be on their corner. They can be at their corners also. Yashraj, very close to the answer. If you reduce 10 from it, you'll have the correct answer. Pranmay, if you multiply your answer by 10, you will get correct answer. Pranshu, not correct. Okay, so I'll mention the 3 cases that you'll have, starting with 3.
Sir, is my answer correct?
Pranmay, correct. Yashraj, correct. Starting with 3, but not ending in 3. Okay, this can be your case 1. Okay. Second case can be starting not with 3, but ending in 3. And third case is both starting and ending in 3. You can realize that this question also has with itself a Venn diagram associated. These are okay, I'll make it properly. This is start 3 and end 3. And this is both. This is 4-digit numbers. I hope you understand that from the entire set of 4-digit numbers, you can have numbers that start with 3, that end with 3, and there are certain intersection region which are both starting and ending in 3. Okay, so these are the cases that you can make. Try to verify that all these 3 cases are actually independent of each other. If a number starts with 3 but does not end with 3, that is completely different from a number starting not with 3 but ending with 3. And that is completely different from both starting and ending in 3. Okay, so if I sort of want to color these regions, case 1 ko I'll color and I'll mention like this. This pink region is the is the intersection region, and this blue region is okay. I've done a tiny mistake. Blue is this, both starting and ending in this. Okay, these are your cases. This is one way to solve the question. Okay, so I'll also mention method 1. If you do it this way, now case 1 ke liye, starting with 3 but not ending in 3, that means if you make digits, first digit has only one choice. It has to be 3. Second digit has 10 choices. Third digit has again 10 choices. And fourth digit has how many choices? It should not end in 3. So that means there are 9 choices. So I'll multiply out all of these and I'll find that there are 900 ways. Second case has, it must not start with 3 but end in 3. So if I write it down, it must end in a 3. So I have only one choice for the last term. It has 8 choices. It has 8 choices for the most significant digit, because 0 is not allowed, 3 is also not allowed. Okay. So, and the middle digits are all 10, 10. So this has 800 ways. And finally, if you start and end in a 3, both of them have one way and the middle digits can arrange in 100 ways. So this becomes 100 ways. You have to realize that each of these cases are independent of the other cases. They are disjoint sets. Disjoint means they don't have any common, pairwise common intersection region. Okay, all are separate regions. And if you add them all up, you will get your full answer 1800. Okay, another way to do it is you could consider the number of numbers that start with 3 only. Okay, so this is method 1. Method 2 is 4-digit or start with 3. Second is end in 3. And third is
Please,
both.
man, correct.
Sumit, not correct. Sumit, you should realize na it should be much larger than the previous answer.
So, but
Because
really,
now
no, so that it can go only up and right and down and
no. So upright means it can go up or it can go right. It can't go down or it can't go left. That is what I mean. Got
means
it?
it can go up, then right, then also it can take right, na?
Then it can take combinations of up and right, but it can't go left. That is what it is. Okay. Both start and end in 3. Okay. So if they both start and end in 3, this becomes like 1 plus 2 minus 3. So if I am having to color them, this is how I'll color them. Red and blue. This I'll color as blue. This I'll color as red. And this 3, both start and end in 3, they will be multicolored. Clear, everyone? So again, over here also it's pretty straightforward. This will be 1000 plus 900 minus 100. And it will give the same answer. So combinatorics mein there are often multiple ways of solving the same question. It will always lead you to the same answer. As long as you have taken care of all the conditions of the question properly. Okay. Try question 24. Achha, anyone who is finding it tough to make notes or something because I'm going slightly faster, I have been sharing the notes link in the class. So you can check it out from the meeting group chat. After the end of the class, I'll update it. You can take it from there. Question 23 we have done. 24 is arrange the digits from 0 to 9 in an order. Okay. You have to find 1 second. First, and you have to find total ways to do this. Second, ways in which 3 or 8 are not in front. Okay. Third is ways in which 3 is not in front and slash or 8 is not in the back. Okay, so you have your numbers from 0 to 9. There are 10 numbers over here. You arrange them in a line. You are arranging them, so you're not making a number. So 0 can come in the first place. That is all about. You have to find the total number of ways in which you can do this, first of all. Second, the ways in which 3 or 8 are not in the front. Okay. I'll edit this to make it proper.
So for the first one, won't it just be one way?
No. So for first one, it will be like you want to arrange not in ascending order. From 0 to 9, there are 10 different digits or 10 different elements that you need to arrange in a line.
Oh, okay, right.
Yeah.
Okay.
Think about it. Ways in which 3 is not in front and slash or 8 is not in the back. We'll be back in 2 minutes. Snigdha, correct answer. Sanyu, correct.
So is my answer for bonus question correct?
Yeah. What were you saying, Sumit?
So is my answer for bonus question correct?
Sumit, I don't remember the answer, and I don't think it would come out so fast. So I'll confirm that answer with you.
So it's 16 factorial upon 8 factorial. It's a simplified form.
Just a second. Sumit, we'll discuss it later. You send me your entire working on WhatsApp later. I'll go through it then. Sanyu, correct for second part. Asmita, I'll explain the question. 1 second.
So can
Snigdha,
I get
correct.
any
Pranshu,
more
correct.
question?
Tuba, correct.
So can you give any more
Sumit, wait.
bonus
Sumit, wait. Sumit. Arnab, correct. Shubhangi, correct. Shubhangi, not correct, sorry. Sanyu, 1 second, I'll confirm. Sanyu, not correct. Try again. So everyone, for first one, don't expand out or calculate out the answer. It is fine if you leave it in factorial. So I'll solve the first question, which is simple. It's straightforward. Arrange the digits from 0 to 9. There are 10 digits. So 10 factorial place. I hope everyone remembers how this is supposed to be done. You make 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many ways how many ways can the first slot choose a particular number in it? The number of ways is 10. And the next slot has 9 options remaining, then 8, then 7, then 6, 5, 4, 3, 2, 1. If you multiply out all of these, you will get 10 factorial. Okay, this is the definition of this factorial symbol. Okay, so first one answer will be 10 factorial. Second and third are like progressively trickier. Second is almost as simple as this. Does anyone want me to wait for second one? Okay, no one is asking me to wait. Number of ways in which 3 or 8 are not in front. Now, how to solve this? You can again make your list of the slots. And now while assigning the number of choices, first slot cannot have 3 or 8, but it has the other 8 numbers as all possibilities, like 0, 1, 2, 4, 5, 6, 7, 9, and yeah, those 8 numbers are all possible. So first slot has 8 possibilities in it. Second slot onwards, there will be one less possibility. Correct. For the second slot, one of the numbers has been used in the the leading position. So the second slot will have 9 choices, then 8, then 7, then 6, then 5, 4, 3, 2, 1, as it is it was done in the first part. Okay. So this will not be 10 factorial. This will be 8 multiplied by 9 factorial. You don't need to calculate it out. If you leave the answer like this, it is enough. Now the task is ways in which 3 is not in front and or 8 is not in back. This is a question now of inclusion exclusion. So everyone can try the third part.
So can you give some?
Arnab, you can take that 8 factorial out common and then tell me what's the prefactor that you get. Sumit,
So
one
can you?
second. I'll give one. Okay, this might be tough. Just a second. Okay, those are done with 24 and with the first bonus question. Sanyu correct, Arnab correct.
So what's the meaning of this question, sir? It's so simple. That
There are 6 distinct colors. They are painted on a cube. What are the number of such cubes possible?
Acha means a single paint can be applied on one more than one face.
No, 6 distinct colors are applied.
So sir, what's the question, sir? It's nothing then.
Certain cubes will look alike. 6 factorial is not the answer.
Sir, it's even simpler than the normal questions then. It's sir, why it is bonus then?
Because 6 factorial is not the answer, na?
Why not?
Think about it. 6 distinct colors are painted on a cube because some cube rotations are involved.
Okay, sir, understood.
Sir, is my answer correct?
Shubhangi, for the bonus 2.
No, sir, Pranamya, for the question number 3.
Part 3 not correct. Try again. Shubhangi, which question have you answered? Okay, part 3 I will solve now. Those who are waiting for the answer of part 3. This is again a question that can be easily visualized using Venn diagrams. So I'll make the first. Universal set. In this, I will have arrangements starting in 3 and arrangements ending in 8 and end in 8. And this is both. What we want is we want either they start with 3, either they end with 8, and both also we will count. So this is for part 3. Way of solving this is you take the numbers. So start 3 wala case. Start 3 case. How many ways can you make this happen? This will be 9 multiplied by 9 factorial. Everyone agrees with this? You can have, I'll just read the question once. 3 is not in the front and 8 is not in the back. Okay.
So is my answer correct for the bonus 2? Sir, for bonus 2, my answer is correct.
1 second. Sumit, not correct.
Sir, Yashraj.
Just a second. Yashraj, not correct. Kaushik, not correct. So what you want to actually find is this region. To find region mein, I will consider this. This is the region that does not start in 3 or end in 8. Okay. So the number of numbers that start in 3 are 9 into 9 factorial. Number of numbers that end in 8 are 9 into 9 factorial. Numbers that start, wait a second, sorry. This will be simply 9 factorial. Numbers that end in 8 is 9 factorial also. Start with 3 and end with 8. This will be 8 factorial. Anyone has confusion in this? Number of arrangements that will start with 3, end with 8. They each will be 9 factorial. Number of arrangements that start in 3 and end with 8, both. That will be 8 factorial. Because you have fixed the first and last digit, there are 8 other numbers that are remaining inside here. They will be arranged in 8 factorial ways. Okay. And total ways is, that is always 10 factorial. So the way to solve this question, finding this red region, is you take the total 10 factorial ways, subtract out the number of ways that start in 3, which is 9 factorial, subtract out another number of ways that start with 8, that end in 8, as another 9 factorial ways gone. Then you will add back the region which both start and end in 8. Because when you were removing the arrangements which start with 3, you had removed certain arrangements which start with 3 and end with 8. That same stuff happened when you removed arrangements that end with 8. Some arrangements were also starting with 3 also.
So,
So if you add back
my
8
answer
factorial,
for
1
bonus 2
second,
is coming.
Sumit, wait. You raise your hand. Once I'm done with my explanation, I'll discuss. Okay, otherwise it keeps interrupting. Answer is not correct, Sumit. So from here, you can take 8 factorial common and you'll get 100 minus 9 plus 8. This is 73 times 8 factorial. I hope part 3 is clear to everyone.
Sir, is my answer correct for the bonus question?
Arnab, not correct.
Sir, is my answer correct?
Yashraj, not correct. Yashraj, not correct.
Sir, it's 30 only, sir.
No, 30 is not correct.
Yes, sir. I also got 30.
Okay, fine. Most of you are getting either 30 or 40. It is not correct. Think about it. Do one thing. You painstakingly take certain number of cubes, paint them, okay, with 6 colors, and then check how many such cubes you are able to make. Because that is the
How will
brute
bring
force.
that much number of cubes, sir? That is illogical.
You all are very Rubik's Cube enthusiasts, na? So go pile up certain number of Rubik's Cubes from your friends and uh, like dismantle them out and then reassemble such that you're making different cubes with 6 colors. And you will be surely done with the number of friends that you have in your classroom. Okay. Answer is less than 30. Okay. If you see 2 cubes that look exactly same, then you have to reject them. All cubes should be different looking, different from rotation. So this third question, I hope everyone has understood. Now the last question that I leave everyone with is
100 minus 9 plus 8 is not 73, right?
+1, sorry, +1. Because I take 8 factorial
So
common,
now,
this will be 73. Just check that once.
my answer.
73.
Now it's coming to 83, right?
So my answer now?
So now will come 83.
Sir, is my answer for bonus correct
One
now?
second, one second, one second. Oh, okay, okay. This is not 100. I did a tiny calculation mistake. See, 100 factorial may see if you remove 8 factorial out common, it will be 9 times 10. I have the
9.
correct answer with me. So 90
Yeah.
minus 9 minus 9, 72 plus 1 is 73.
Yeah.
Okay, sorry for that. 1 second. So it's still not correct. Okay. I'll leave you guys with one final question, which you can, at this point, possibly solve on your own if you were struggling. 25th question.
Sir, now?
Sumit still not correct. Shubhangi not correct. Sumit, this way you will give all possible numbers and then one
No, sir,
at some
sir,
point you will get the answer.
Sir, what I sent after 30 was just my intuition.
Don't give guesses at this point. You should, once you are, do one thing, next answer, whatever you send, you give me full writing proof for how you got that answer, okay? Last question, which I'll not discuss today in classes, numbers from 1 to 567. How many are divisible by 3, 5 or 7? So this means 3 and or 5 and or 7. Okay. So all the numbers that are divisible by 3 or 5 or 7, which includes number being divisible by 15 also, 35 also, 21 also, and 105 also. Okay, so try to do this question. The way to solve this question is to make a Venn diagram like this, and then do some inclusion exclusion that you have learned in today's class and try to solve. Okay, so this is homework. 2 weeks later when we meet, I will give you the answer to this question. Any doubts in today's class contents anyone has?
Sir, just check my answer once.
It's not correct still. I'll now discuss the answer to the first bonus question that I had given.
Sir, can I tell?
1 minute. In the interest of time, I'll just solve it. And has everyone attempted this question? Someone wants me to not give the answer so that you can attempt it after the class. Yashraj, not correct.
Sir, for the previous question, before this bonus.
Not correct. Acha, this one. Correct.
Yes,
This one is
homework
correct.
question.
25th, 20.
So is it
This
correct
bonus
for the
question.
homework question?
Correct. Does anyone want me to not give the answer to this question right now?
So
No
can you do the ant one? Or will it take
Ant one.
too long?
No, ant one actually, I have given that question to be discussed at the very end when I'm completing with combinatorics. At that time, I will give the answer. So,
Okay.
Tuba correct answer. Sinha, sorry, Shubhangi, question 7. Where is question 7? Arnab, not correct, very close. Okay, the way to solve this question is, you have.
Sir, is my answer correct for this bonus?
Yashraj, very close, not correct, but you're one less than the correct answer. So we have 31 plus 1 multiplied by 19 plus 1 factors of n. And the way to do that is simple. If you have 2 to the power 2 to the power a multiplied by 3 to the power b multiplied by 5 to the power c and so on, number of factors is simply a plus 1, b plus 1, c plus 1 and so on. The reason for that is simple. In case you have a query in that, you can ask me in the next class. Tuba, not correct. So these are the number of factors of n. Okay, for now, I'll just let a is equal to 31 and b is equal to 19 because that will be easier for my calculation. Number of factors of n square. This will be how much? This will be, first of all, n square is equal to 3 to the power 31 times 2
Sir,
multiplied by
so now I can calculate for any value that you give. Sir, give any value.
19 times 2. And this will have factors 2a plus 1 times 2b plus 1. I hope everyone is clear with this. The power is 2a and this
Sir,
power is 2b.
I did something by subtraction and I got one very basic formula.
Wait, Sumit. I'll complete with my explanation, then we'll have other discussions. So, these are the number of factors for n square. One thing that you need to keep in mind is number or if I have this n square, if n square is equal to k times l, what we'll have is either k greater than n, l less than n, or k less than n, l greater than n, or k equal to l equal to n. Does everyone agree? If we write n square as split into two factors, k and l, then I can be sure that one of them is greater than n and another has to be less than n. Is
Yes, sir.
everyone clear with this? So this implies that half of my factors of n square will be less than n, half of the factors will be greater than n, and there will be one factor that will be exactly n. And that also makes sense because 2a plus 1 and 2b plus 1, this is an odd number. So number of factors of n square less than n can be simply found less than or equal to n. Can be found by 2b plus 1 and 2a plus 1. I'll add 1 to this and I'll divide this entirely by 2. Because these are all the factors of n square less than n. This is n. And these are all the factors. And then you'll have in the end, you'll have n square also over here. You'll start with 1. So these are all the factors of n square if arranged in ascending order. You'll have the numbers from 1 to just less than n as factors of n square. Then you'll have n. Then you'll have factors of n square that are greater than n up till n square. It is known that for each of these factors, there will be another factor in this list. So that means the size of both of these lists are equal. That is why if I add a 1 to it and divide by 2, I'll get number of factors of n square that are less than or equal to n. Why did I do all of this? Because the question is asking me to find the number of factors of n square that are less than n and do not divide n. So first part is finding out how many factors of n square are there that are less than n. Then I'll remove out all the factors that divide n. Any factor that is a factor of n will divide n square also. Correct. So number of factors of n square less than or equal to n. This is directly 2ab plus a plus b plus 1. I've just simplified this out. Okay. And number of factors of n.
So it is less combinatorics, more algebra and number system.
Yeah.
We can say it is combinatorics. Only the formula is derived by
in the end,
combinatorics.
there will be lots of questions that are based on
Everything.
multiple topics. Yeah. So number of factors of n less than or equal to n will be, this is simply a plus 1 into b plus 1. So answer will be 2ab plus a plus b plus 1 minus a plus 1 b plus 1. And if you notice, this will be 2ab plus a plus b plus 1 minus ab minus a minus b minus 1, and everything will get cancelled. And you are left with ab only. That is why I had replaced the power of 31 and 19 over here with simply ab. You will get 31 times 90 is equal to 589. Okay, this takes care of everything. If you think in your head, okay, 1 should not be part of my list, 2 should not be part of my list, 3 should not be part of my list, and so on. It will take a long time to actually count up all the numbers. Correct. Rakshit, I will give answer for bonus 2, which is this distinct color cube, not in
Sir,
today's
please.
class, not in next class. In next to next class, I will give, which is
Sir,
1
can
month
you-
later. Okay, so you can keep thinking about it. See, I also have to introduce this topic, and we'll do certain number of questions based on rotations and all.
Sir,
And that
was
will
my answer correct
be a
for
bit.
that question? You told that two ends can move only up
No,
and
no.
right and down.
I'm not 100% sure. I'll check and let you know.
Sir, I'm rewriting my answer, sir, please.
You do one thing. You send that to me on WhatsApp. I'll check it there.
So solution
Okay.
also?
Solution also everything.
Okay.
Okay. So I'll update this note. You can, if I have sent the link already on the chat, you can view it from there. Just refresh that note. I'm resending the note link. Acha, oh, Sinha, sorry, Shubhangi, you're talking about this question. Question 25. How many are divisible by 3 or 5 or 7? So I want all of these. This entire thing. But individually, whatever you have found is correct. Arnab, not correct. Try again.
So can I like send you the concept?
Yeah, you can. I'll end the meeting right now. We will meet 2 weeks later. Bye, guys. Acha, also, in case you don't have my phone number and want to contact me, I'll just put that in the chat.
So also just like I just sent the concept. Can you just check if it's right?
Where have you sent?
On the chat. I just
Correct.
Okay.
Chalo. See you guys later. I'll end the meeting.
I say
Bye.
thank you, sir.